All right, the next topic we're going to discuss, functions and their graphs. Because up until now, we've talked about equations. What's an equation? Yeah, an expression, exactly. It's a beautiful way of saying it. An expression with an equal sign. Because what is an expression? An expression is simply combining like terms. But if it has an equal sign, that means that combining of like terms has to equal something. So we have to solve for a variable. For example, the first one of the equations we used was this. Nope. What is this called? What is, yes, because M is the, and B is the y-intercept. You're going to find out that mathematicians have zero imagination. So this equation is called the slope-intercept because it has a slope and intercept. So for us to do this, I define the variables M and B. How would you find some points? Find 2 points on this equation, on that graph. It's pretty easy. Since it equals y, choose any value for x. Choose anything. So I'm saying that x is equal to -3. Once you choose that, plug that value into the equation and solve for the y value. So here's my equation. I'm saying that y is equal to 3x plus 2. I'm saying x is equal to -3. So anywhere I see an x, what do I put in its place? Yeah, so here, anywhere I see an x, I put a -3. Pretty easy, straightforward. It's plug and play. Now I work it out. Positive times negative is 3 times 3 is 9 plus 2. So here we have different signs. Is the answer going to be positive or negative? 9 minus 2. So that's what the answer is. Because it's an equation, it also can be represented in a graph. So as a graph, remember, a graph has points. A point is an ordered pair, x and y. So for our equation, we said x was -3, and we calculated -7. There's 1 point of our graph. We're asked to find 2 points. So let's pick another one. Let's say x is equal to +3. Does it matter which x you pick? No. Because if everybody picked their own 2 values, well, what do we know about this graph of this equation? What's the graph going to look like? It's a linear. Why is it linear? It doesn't have an exponent, right? Yeah, exactly. A root works for square roots, radicals. So it doesn't have an exponent or it doesn't have a square root or radical. So we know because of that, it's linear. What do we know about straight lines? In order to draw a straight line, what do you need? What's the basic you need? 2 points. So once we find 2 points, we plot them and draw it. Are all of our, if we use different x's, will we get the same graph? I use -3 and 3. If I told everybody, okay, do it yourself, pick your own two numbers, will we have the same graphs?
Yeah.
Why?
It doesn't matter about what points you pick. It will be the same because of location.
It's the same equation, exactly. Because this equation has an infinite number of points. So we can pick any x we want to, plug it in there. Because of this equation, we'll get this, all of our points will be on that line. May not be the exact points, but it's still, if we draw a line, it's going to be on there. So in here, we have y, the equation is 3x plus 2. I said x is equal to 3. So in place of x, I put 3. And I work it out. They're both positive, so the answer is positive. 3 times 3 is 9. 9 plus 2 is. So the point on the graph here, x is 3, y is 11. So these are my 2 points on the graph. Pretty straightforward. So that's how, if I give you an equation, ask you to graph it, that's how you'll do it. One of the methods is just plug some points. As long as we know what it looks like. Because if it was an x squared, we know it's a curve. So we have to pick a bunch of points to see where it's going down, where it's going up, to see what the shape is. Now, you noticed we have two variables here. We have a y variable and we have an x variable. They have names besides x and y variable. Can we find this value without knowing this? Without knowing x? Can we solve for y without knowing x? No. So x can be anything you want to. Because of that, it's called the independent variable. X can be anything. Any number. It can be any number. You choose. Once you pick it, once you define what x is, you plug it in there. We work it out. And now, does the value of y have any say in this thing? No, it is what it is. So that's how come the y variable is called the dependent variable. Its value depends on x. So whenever we talk about independent, dependent variables, that's what we're talking about. The value of y depends on what x do we put in there. Do you have to have independent variables? What about that graph? What is that graph going to look like? Very good. There's no x in there, right? So it will be always 3. No matter what x you give me, the answer is always going to equal 3. It's a constant equation. It's a horizontal line. What's the slope of that one? Very good. The slope of this one is 0. Because you will be faced with word problems. It's going to say, find the equation of the line going through this point with zero slope. Let's see this. Find the equation of the line going through -3, -5 with slope 0, or with 0 slope. That tells us a lot right there. Think about it. Okay, so we know the slope is 0. It's going through the point -3, -5. So let's look what that looks like. -3, -5. So it has to go through that point. What's the graph of a slope 0? Remember, if it's a slope 0, it's a horizontal line. Or conversely, if I gave you this picture, find me the equation. So what's the equation of this line? Y equals -5, because this is the y-axis. Where does it cross the y-axis? At -5. So if your slope is 0, then your equation is simply the y value. If your slope is 0. If your slope is undefined, what is that graph going to look like? If it's undefined. Yeah, it's a vertical line. Because remember, for a slope to be undefined, what has to be true? The bottom has to equal what? The bottom has to equal 0. Because a fraction is undefined if 0 is on the bottom. So if 0 is on the bottom, that means that x1 equals x2. That means all of the x's are the same. So this one is undefined. So what's the equation of the undefined line? Undefined slope. It crosses there, so the equation is where it crosses. That is your equation of if the slope is undefined. It's simply the x value. Yeah, it sounds easy, but it's very easy to get confused also. But think about it. If it's a horizontal line, in this equation, can we have an x-intercept? Yes, because there's an x value there. If you have the variable in there, you can cross that line. So we can have an x-intercept, we can have a y-intercept. This graph looks like this. It crosses the y-axis and it crosses the x-axis. So what does that mean? If you have the variable in the equation, then you can cross that axis. If there's no x in the equation, I cannot cross the x-axis. That's how come this one is a horizontal line. 3. You can only cross the axis if it is in the equation. Make sense? Kind of, sort of. If it doesn't exist, it can't cross it. Kind of like if it doesn't fit, you must have quit. If it doesn't exist, you can't cross it. So let's get back to the. I'm of course going on tangents here because it's a perfect place to put this, and we'll talk about these more in a little bit. So we're getting back to. We're trying to define functions. We know what equations are. So we have these right here. So an equation versus a function. So this is like y equals 3x plus 2. If you have an equation, you need to define the values of x. In other words, you have to define what it means. Like that. Yeah, that's okay, but it's a lot of extra writing. We have the equation, you have to x equals. Because once you have this, then you come up here and put y equals 3 times negative 3 plus 2. Y equals 3 times 3 plus 2. Y equals 3 times 0 plus 2. That's what it means, right? It's much easier when we use functions. A function defines the equation in a unique way, but it incorporates my definition of x. So instead of y, we use a name for the function. We give the function a name. So this equation is called by the function f. The way this is read, it says the function f of variable x is 3x plus 2. That's how you read it. The function f of variable x is equal to that. We shorten it to say f of x is 3x plus 2. So this whole sentence is shortened to that. Now, what this means is whatever's inside this parenthesis here, that defines that variable. So let's say, if I wanted to put negative 3 in there, I do that. You see how much less writing it is? Because instead of writing y equals this, I just put f of negative 3 is this. So what does this tell me to do? Yeah, anywhere I see an x, I put a negative 3 in its place. That's what it tells us. Whatever's inside the parentheses goes in place of every x in there. Work that one out for me. How would you read that? Yeah. G of 2 is equal to x squared plus 3x plus 1. Remember, mathematics is a language. We have to be able to communicate it in words. But what does this mean now? What does this 2 tell me I have to do? Yep. Any x I see in the equation, I put a 2 in its place. So 2 squared is 4. 3 times 2 is 6. 4 plus 6 is 10. 10 plus 1 is 11. So g of 2 is 11. Okay, here's the beautiful thing about it. Is once I define what g of x is, all I have to do is this. Once it's defined, it says, okay, go to the function called g, and in place of x, put a 0. So I have 0 squared plus 3 times 0 plus 1. That 0, so it equals 1. What does this going to tell me to do? Yep. Anywhere I see an x inside my equation, I put a -1. So -1 squared plus 3 times -1 plus 1. What is -1 squared? +1. Positive times negative is negative. 3 times 1 is 3 plus 1. 1 plus 1 is 2 minus 3. We'll go over the rules in a second why I could do that. Because normally you would do what? If I had this, what would you do first? 1 minus 3, left to right. And then from there, but there are certain properties we can use in mathematics where we can move things around. And we'll do that in a second. So 2 minus 3 is, since 3 is bigger than 2, it's negative. The answer is negative. 3 minus 2 is 1. Answer is -1. So this is how we use in functions. This is how most of mathematics deals with equations. We don't deal with y equals or anything equals. We f of x, g of x, h of x. You can give it any name you want to. I'll show you. I'm defining this function, f of x, as x squared. I'm saying g of x is 2x minus 3. I'm saying h of x is x over 2. I've just defined my functions. Find me those answers. So the first one, it tells me go to the function f. Here's the function f. F is x squared. So in place of x, I put 2. So it's 2 squared, which becomes what? 4. The next one says go to function g. Here's g. In place of x, I put a -3. So in here, I have 2 times -3 minus 3. Positive times negative is a negative. 2 times 3 is 6 minus 3. They're both negative, so the answer is negative. So we add them. 6 plus 3 is 9. And the third one, I go to function h. In place of x, I put 4. So I have 4 divided by 2, which is 2. But now we can mix everything up. Yes.
So, when you multiply the 3 and the -3, you got. What did you get? You got
Yes.
a negative something negative.
That's positive 2 times -3. So positive times negative is a negative. This is not multiplication. This is subtraction. It would be multiplication if I had -6 times -3. But it's a subtraction problem. How about this one? What is this telling us? What does this mean? Yeah, 2 times the function of f at -3 plus g of 0 minus 4 times h of 6. So what's the first thing you have to do? Yeah, plug it in. So we have 2 times f is here. It's in place, it's -3. Because that's what the function f is, x squared. In place of x, I put a -3. Plus, I go to g. In place of x, I put a 0. So I have 2 times 0 minus 3 minus 4 times h of 6. H is x over 2. So x is 6. That's how functions work. We take an equation and instead of having writing it all the time over, we define it once and now we can use it any way we want to. What is -3 squared? Positive 9. -3 squared means -3 times -3. That's what that means. Negative times negative is a positive. 3 times 3 is 9. Plus 2 times 0 is -3. So there's that one. Minus 4. What is 6 divided by 2? So I just do each part separately. 2 times 9 is positive 0, -3 makes it a -3. Minus 4 times 3 is 12. So we have 18 minus 15. I just changed the rules on us, didn't I? But since they're both negative, I'll put those together first. -3, -12 is -15. So 18 minus 15 is, you say 13. Let's go over the rules there, the properties. Why we could, because yes, when we first talked about the order of operations, we have to read left to right. But we have what are called the properties of algebra. or properties of math, actually. The order by person tells us when to do it. This tells us what we can do. So the first property we're going to talk about. The first property is the commutative property of. What does it mean when you have a colon at the end of a statement? There's a list. So we have two types of commutative property. What does commutative mean? What does to commute mean? To move, yeah, to go, to move. You commuted from home to school. This means to move. This property deals with moving. To commute means to move. So the first one we're going to talk about is the commutative property of addition. What this one says is if we have two numbers, x and y, x, any number x, any number y, if we add them together, that's the same thing as if we take y plus x and put them opposite ways. So, for example, 3 plus 4 is the same thing as 4 plus 3. They both equal 7. So it doesn't matter how we arrange them. I can move them around. Did I do that? Yes. With my last example, I moved them around. Who did I move? That's when we started. Anyway, I'm moving them around somewhere. Oh, this one here. Since I have this one and I have this one, I can put those together. 1 plus 1 is 2. That's the commutative property. Say you can't do anything in math unless there's a rule says you can do it. Okay, so that's the first one. The second one, commutative property of multiplication. What this one says is x times y is the same thing as y times x. 3 times 4 is the same thing as 4 times 3. They both equal 12. So that's the first property. Tells us we can move things around. The second property is the associative property of. What does to associate mean? Kind of, but not really. When you associate with your friends, means what do you do when you associate with your friends? You talk to, you communicate, but what have you just created? A network or a group. You're not really combining this yet. So this one deals with grouping. Because it's got a colon, we have two of them. We have the associative property of addition. Because now we're making larger groups. So here we have x plus y plus z is equal to x plus y plus z. Is that a true statement? But here's the problem. Nothing in our known universe can process more than two pieces of information at any one time. Even the fastest computers, they break it down to two numbers. So which two do we add together first? Well, this is where the grouping comes in. This is the introduction of a parenthesis. You have to tell me which two do I put together first. That's what that tells us. Have we seen parentheses before? Yes, order of operations. Let's see here. So we have 3 plus 4 plus 5 is equal to 3 plus 4 plus 5. Because obviously x plus y plus z is equal to x plus y plus z, which means those same numbers, we can combine them. So first thing we do here is what? On the left side. We have to do inside the parentheses. 3 plus 4 is 7 plus 5 is on the right-hand side. We have to do 4 plus 5. So 4 plus 5 is 9. 9 plus 3 is 12. Not too impressive, but the next one is we're going to show us the true power of this. So the next one is the associative property of multiplication, which says x times y times z is equal to x times y times z. Can we multiply x and z first? Yeah, by commutativity. We can move them around and multiply those together first. So we have 3 times 4 times 5 equals 3 times 4 times 5. Left-hand side, what do you do first? Inside, so 3 times 4 is 12. Then 12 times 5 is? How did you get 60? What did you do? But mathematically, what did you do? Multiply 5 times 2 is, that's a 0, carry the 1. Then 5 times 1 is 5, plus 1 is a 6. This is a simple one. What if I gave you 14.7 times 36.2? So listen, but mathematically, this is what's going on. Even in your head, that's mathematically what's going on in your head. Because it's not intuitive, 12 times 5 is 60. It's in your mind, you've seen it enough times, you process that really quick. On the other side, 4 times 5 is 3 times 20 is. Which side is easier? Which side the process would give you less chance of mistakes? The right side. By definition, because how would you do this? How would you multiply 12 times or 37 times 6? Do that in your head real quick. You can't. As you can't, you have to go through the process. Saying, I gave you simple numbers here, but think of the mathematical process going through your heads. You have to first do 5 times 2, 10, carry the 1. The more you write, the more chance of mistakes you have. This one is labor intensive. What about this one? Anytime you multiply anything that ends in a 0, all we have to do is 3 times 2 is what? With it ends in a 0. So if I give you 7 times 30, what is 7 times 3? With a 0 at the end of it. Or 20 times 40. What is 2 times 4? 8, with 2 zeros behind it. So whenever you multiply with zeros. So this is the proof of why the associative property is powerful. you can pick what numbers you multiply together first to make it easier for yourself. Yes, by all means, this is a lot easier than the other side. I guarantee you, you'll make more mistakes here than you will on this side. So that's the associative property. Just notice how we had to separate these operations, addition and multiplication. The next property is we put them all together. The next property is probably the most powerful one. The distributive property. You notice there's no of at the end of it, because this one combines both addition and multiplication. This property combines multiplication and addition. This property is used to remove parentheses and to factor equations into smaller parts. In other words, we introduce parentheses. So this is a powerful rule. We can take away parentheses, we can put parentheses in, and we combine. So this is what it looks like. So we combine both multiplication and addition. What is this number in front of the parentheses called? Called the coefficient. It could be a number, it could be a letter, it could be a symbol, a sign. It could be anything. Whenever you have a parenthesis, you always have a coefficient in front of it. If there's nothing there, the coefficient is 1. Now, where's the multiplication here? Yeah, it's a times this. So what this, the distributive property is, everything in front, the coefficient multiplies to everybody inside the parentheses. So a times x is a times x. Positive times positive is positive. A times y is a y. That's the property of distributivity. We got rid of parentheses. We had parentheses here. Now we have no more parentheses. How many of you ever took chemistry in high school? There's a process in chemistry that is called stoichiometry. Stoichiometry says something like this. If you had H2O, it breaks down to what? No, it is water. So we have 2 hydrogen and 1 oxygen. But more so, you have these arrows here. What do those arrows mean? Well, think of it. It means I can go from this to this. Or I can go from here and get this. That's what equal means. For equality, 3 plus 2 equals 5 is actually like that. I can go both directions. Whenever you see equals, you have to be able to go both directions. So what this tells us is I can go from here to that. Or if I had this, I can go from there to this. Two different names. If I go from this to this, if I remove the parenthesis, that's called distributivity. If I go from here and I introduce the parenthesis, that's called factoring. Factoring is, what do they have in common? Whatever they have in common, that goes outside. And then whatever's left goes inside the parentheses. That's why this is a powerful tool. We're going to be using both of these properties, both of these aspects of this property throughout the rest of this course. Then we have the identity property. We have of addition and multiplication. What the identity property is, what do I do so that whatever I start off with doesn't change? So what times x, or what x plus what will give me x? Or 3 plus what gives me 3? 0. That's the identity. So if I add 0 to anything, I don't change it. How about multiplication? X times what gives me x? X times 1. 3 times 1 is 3. That's the identity. I don't change it. It doesn't change. So if I use addition, I add 0 to it. If I use multiplication, I multiply by 1. So anything times a 1 is itself. The inverse property of we have addition and we have multiplication. Now, what this one says, the inverse. What do I, x plus what gets rid of it? It gives me 0. So 3 plus what gives me 0? Minus 3. So it's negative x. So if I add the same number but different signs, they disappear. So negative 3 plus 3 is 0. 5 plus negative 5 is 0. So the inverse is, how do I get rid of it? What times x gives me 0? 0. Anything times 0 is 0. But we're going to be using the additive property a lot. Think about it. If I had x plus 3 equals 5, what this says, this tells me a lot. Because I have an equal sign. When you have an equal sign, that means you have to solve for something. What are you solving for? The unknown, the variable. So how do we get the variable by itself? We have to get rid of 3. How do we get rid of 3? Yes, by the inverse. Since it's a positive 3, I got to do a negative 3 to both sides to keep equality. So x 5 minus 3 is 2. And there you have it. It seems Mickey Mouse and trivial, but again, if it's so trivial, then you should never make a mistake in math. The only reason you make a mistake in math is because you get overconfident. Oh, unity. And the last one is called the unity property. Of addition and multiplication. There's unity. What do you think unity means? The basic unit is 1. For example, if I had x, what times x would give me 1? If I had 3, 3 times what equals 1? One third. Because what is 3 times 1 over 3? Can anything cancel top and bottom? Yeah, the 3's can cancel. So the unity is the inverse, the reciprocal, I should say, not the inverse, the reciprocal. And there really isn't one to make it 1 on the first one. So we're looking for this one here. That's an important one. All right. So let's get back to functions. So this is how we move things around. Again, you cannot do anything in mathematics unless one of these properties says you can. Again, if you memorize them, then again, there should be never a mistake in math. Every test should always be 100 because the rules never change. Okay. Let's define a function. A function is a correspondence between members of the first set called the domain to members of the second set called the range. But it's a little bit more strict than that. A correspondence between members of the first set called the domain to members of the second set called the range, such that each member of the domain corresponds to one and only one member of the range. okay, these words they use are not by happenstance. What does correspondence mean? Have you ever heard that word before? Probably not, since you never mailed a letter. In the old days, it used to be called correspondence. Whenever you sent a letter to somebody, that's the same thing now with email. You're corresponding when you send an email, or actually back in the days, when you sent a letter to somebody, and you send that same letter to more than one person. You can send copies. No, it has to be the same letter. Can that same letter go to two different people elsewhere? No, it's one to one. That's why it's correspondence. The person here sends a letter, a correspondence, to a person there. That's what we call one to one. This is my domain. This is my range. And yes, we use X and Y's for those also. So remember your independent variables, X's, those are members of your domain. Your X values are your domain. The Y values, the answers, are members of the range. In this one, if I picked one value of X, can it give me more than one answer Y? No. I plug it in there and I get 8. That's a one-to-one relationship. That's a correspondence. So I go from this to that. We call that a mapping. So this is how you'll see it in most math and logic books. So here's what it's saying. You have all of your members, your elements of your domain, ABC. And you have your members of your range, ABC. A correspondence that's an example of a correspondence. Each element here sends one and one correspondence to only one member on the other side. Is that a correspondence? Again, the only thing you have to look at is how many arrows are coming out of these? One. Only one. So it has to be a correspondence. Because a non-correspondence would look like this. This one sends to two different people. That's not a correspondence because you cannot have two letters going from one person to another. Think about how if you're dating. If you're dating, you only have one other person to talk to. Is this dating? No. This has got another name. If something like this happens, that's called a relation. A relation is if one member from the domain sends to more than one member of the range. So any element in the domain corresponds to at least one element in the range. So that's a relation. A correspondence of function, corresponding function is 1-to-1. And the easiest way you could do that is look how many arrows are coming out of the left side. If there's more than one arrow coming out of the left side, it's no longer a function, it's no longer a correspondence, it's now a relation. As opposed to if it's only got one, it doesn't matter who it goes to. Let me give you some other examples. So here we have in the first, the domain and the range. Remember, domains are all the values of X. All of our independent variables, those are our domain. The range are all the Y values. So a function must be 1-to-1. So what does that mean? What does 1-to-1 mean? For each element in the domain goes to one and only one element in the range.
So that the domain cannot have two ranges, two y-axis, or y-axis cannot have two x.
The X cannot go to two Y's.
And the range cannot.
Well, the range, as we said, the range can get all of the answers. It can get all of them. It doesn't matter. You don't go that way. You always go from the domain to the range, from independent variable to dependent variable. So it has to have only one, no matter what it goes to. It has to be one arrow only. Now, it may be easier if we look at it in terms of points. Or, I mean, let me do this one first. So we have -6 and 6, -3 and 3, and 0. Remember, the domain deals with the X values. The range deals with the Y values. What if the Y value, remember that's an equation. What if my range was that? What if my range, remember the range is the Y values. The Y equals an equation. So how would I do the mapping here? How to do the arrows? -6. -6 squared is what? So that's that. How about 6? How about -3? How about 3? How about 0? Is that 1-to-1? Yes. Because each one of these only have one arrow going out of it. Don't care about this side. Look at this side. Is if your X value only appears once, then it's a function. Let's look at these points. Let's look at these as points. So we have negative 6, 36, 6, 36, negative 3, 9, positive 3, 9, and 0, 0. Is this a function? Yes, because only thing you have to look at are all the x's different. If all the x's are different, it's automatically a function. Is this one-to-one? Is this a function? Why not? Yeah, but here's a negative 6 and here's a negative 6. Are they the same values? No. That's all it takes is one of them to ruin it for you. Is that a function? Who says yes?
No. it's
You're
not.
absolutely correct. It is true. These are the same negative 3's, right? They have the same value. These are the same points. There's nothing different about them. These are the same x's. They have the same y's. These are the same points. So this is one-to-one. It's a function. If the x's are different, it's automatically a function. If all x values are different, then it is a function. It is one-to-one. If any x values are the same, then the y values must be the same to be one-to-one. So if you see two x values are the same, look at the y values. If the y values are different, it's not a function. They have to be the same. If x is the same, then the y's have to be the same. So far, so good?
So you said the X value and the Y value. X.
No, if I had multiple x values, if you have multiple points that have the same x values, and the y values are different, then it's not one-to-one. If the x's are the same, the y's better be the same. Is the first one a function? Why? Yeah, because the x's are the same, different y's, not a function. So not one-to-one. Is the second one one-to-one? Yes, it is. Since all of the x's are different, it's automatically a function. If all the x's are different, it's automatically a function. How about the third one? Same thing, because all the x's are different, it's automatically a function. Okay, we did that, we did that. We won't talk about that just yet. Let's look at graphs of functions. Remember what I said. If you have a graph, if you have a function, if you have the same x value, let's say it's 1, and if I have two y values, this one is 1, 1, and this one is 1, 2. Is that a function? Why? Because the x values are the same, but the y values are different? Not a function. So if the same x values with different y values, well, here's what it says. You notice how they're on top of each other? That's called the vertical line test. The vertical line test. If you draw a vertical line anywhere on the graph, and it crosses and it crosses the graph more than once, it is not a function. It's not one-to-one. So if I give you a picture and you could draw a vertical line anywhere and it crosses it more than once, it's not a function. Everybody got it? I'll show examples in a second. Yeah, don't copy the word. Abbreviate if you have to. It makes possession. That's again. Is you don't have to copy everything down. Now, is the first one a function? Yes, because I could draw. It never crosses it more than once. Is the second a function? No, because everyone's that. Third one? No. Because fourth one? No. Fifth one? Yes. Sixth one?
No,
Why not?
because it's hitting, the,
This one here?
yeah, that one.
No. This is a function. Because the only place where it could overlap is at -1. But if you look at it, this is a solid dot. That's an open dot. What's the difference? Not include. So if it's a solid dot, I can include that point. If it's an open dot, I cannot include that. So when I go in this graph, this point here doesn't exist. It's just that's where the line stops. I can't use that point. I jump up here, I start with that point and go from there. So a solid dot means I can include that point. Open dot, I cannot include that point. Let's see here. Okay. Any questions about that? If you have a graph, it's much easier. If not, then we have to look at functions other ways. So let's talk about domains of functions now. When we talk about domains of functions, what are we looking at? Yes, we're looking at here what X values can be included? And this is a whole topic we're going to discuss later on as well. For example, what X values can I not use there? Right. Here, my domain is X cannot equal 0. Why? Because what's the only thing you cannot have on the bottom? A 0. So the only thing I cannot have here, X cannot be 0. That's the only restriction of my domain. It could be anything else, but it cannot be 0. Example 8. Here's the first one. A. F of 1 and F of 6. Or F of 3. What would F of 1 give me? And then what would F of 3 give me?
That whatever goes to one, X is one goes with the one.
So what's my answer?
Um,
You left with the one, the one minus three.
And it equals what?
oh, negative 0.5.
Don't ever convert decimals. Leave it as fractions. No. Negative 1.5. Because on top we have a 1. And if we put a 1, we have 1 minus 3. That's 1 over negative 2. So the answer is negative 1/2. Again, don't take shortcuts. Write it down, work it out. How about F of 3? Undefined. Why? Because on the bottom, 3 minus 3 is 0. We get 1 over 3 minus 3. We could have determined this earlier. Whenever I give you an equation that's a fraction, the first thing you should do is tell me what x's can I not use. What's my domain of this function? Are there any restrictions? You cannot have what on the bottom? You cannot have 0 on the bottom. So I take the bottom, set it equal to 0. So if x equals 3, what happens? Then I get a 0 on the bottom. So my domain is x cannot equal positive 3. Whenever you have a fraction, take the bottom number, set it equal to 0, and solve for x's. These are the x's you cannot use. Okay, that's with fractions. We haven't talked about, go ahead, you're finished. We haven't talked about these other ones, but let's look at this anyway. What if I have g of 16 and g of negative 7? G of X is this equation. What's my domain of G of X? What's my domain? Okay, we haven't talked about this yet. But in G of X, we have the square root. What's the only rule we have about square roots? Cannot be negative inside there. Because remember, for a square root to exist, what does that equal? Square root of 4 is 2, because 2 times 2 equals 4. I cannot take square root of negative 4, because no two numbers multiplied together will give me a negative answer. You can't say negative 2, because negative 2 times negative 2 is positive 4. So, with square roots, the domain is x has to be strictly greater than or equal to 0. You can take the square root of 0, that's 0. But you cannot have a negative inside there. So the domain is all x's have to be 0 or greater. So if I did this one, can I do this one? Yeah, because x is bigger than 0. So I can do this one. Can I do this one? I can't do this one because x is negative. But I can do this one. So I have g of 16 is equal to the square root of 16 plus 5. What is the square root of 16? Plus 5 equals 9, right? And see, and the next example, I'm not going to waste your time with it because I'll show you what they look like. It says, find me the domains of each of these. The only one we can figure, what's the domain of this one? Let's look at that one. What's my domain? We know automatically x cannot equal what? No. X cannot equal 7. The 0 cannot be on the bottom, so x cannot equal 7. But what if x is 6? Does that work? Can we have negative on the bottom? In fractions, the only thing you cannot have on the bottom is 0. It can be positive, it can be negative, it just cannot be 0. So my domain is simply that. What if I gave you this? Now what's my domain? We have a couple of rules now. It cannot be negative inside there. So the smallest it can be is 0. Can you have a 0 on the bottom? No. So we know automatically that x cannot equal positive 7 because it makes it 0 on the bottom. Can it be 6? 6 minus 7 is what? Negative 1. So we can't have that. We cannot have a negative inside there. So our domain is strictly greater than 7. Because we're building up our knowledge of these functions. In a square root, inside there, you cannot have a negative. But since it's on the bottom, you cannot have a negative now, and it cannot be 0. So we have to look at both of those conditions. So all of our x's have to be, make sure this is positive.
So automatically, we see that x minus 7, this not like x cannot equals to 7.
Well, we know because inside there, since it's on the bottom, it cannot equal 0. So what would make this equal to 0? X equals 7. So it's x minus 7 equals 0. Move the 7 over there because it's positive. So x cannot be positive 7 because it makes it 0. But it cannot be anything smaller than 7 because it'll make it negative. So you have to look at the whole equation, not just inside there. It's on the bottom, so it cannot be 0, and it's inside the radical, it cannot be negative. Next time in class, we're going to do, we'll go through, look at all the library functions. Because for us to go any further, you guys have to know what the functions you're dealing with, what they look like, what they mean, what the restrictions are. So we'll start off next class looking at that. Let's see. Do we want to do the next one? What time we get out of here? At 11? I'm playing. All right, let's start the next section.